test. Sure. Yeah, give them an IQ test, right?
Maybe get more specific with the city or the schools.
Whoa, okay, all right. So if you want to get more specific with the cities or the schools or something else, we got to back up and rephrase our question. So now we have a different population we're looking at. It's a narrower population. So which is it going to be, all 11th graders or 11th graders with some sort of criteria? I need to have a little thing like on this kids in it.
All 11 graders.
Okay, so we're back. We're back to the original. Okay, all 11 graders. So I want to know right now in this climate and what's going on right now. I want to know on a cross section of 11th graders, and I want to know their IQ. Okay. Give them an IQ test. So all 11th graders, do I give all 11th graders an IQ test? We don't even know, are we talking about America? Or are we talking about global? We're not going to give all 11th graders the same IQ test. There's a lot of problems with that, okay? Instead, we're going to do what? We're going to take a subset of 11th graders, which is called a sample. So let's say that we're looking at, if we're thinking about all 11th graders, let's say we have the resources to get 200 11th graders, okay? So we're going to give 200 11th graders the IQ test, the same IQ test. And then we're going to find out what they got. And is that the end of our study? Because we want results, right? But you're saying no, it's not the end? Yes?
You have to look for outliers and make sure the data is consistent.
There's always outliers. Sure, there's always outliers. What we do with outliers usually is kick them out. Here is the big problem, the biggest problem in stats. Happens the relationship between the population and the sample. I'm going to be asking you that a lot. Test. The biggest problem, I should say one, of the biggest, most fundamental concerns is the relationship between a population and a sample. And here's why. If I were to take a sample of 200 11th graders, okay, I'd have to make sure, or hope, do my best, that they're going to represent the population, okay? So if I find out the 200 people I gave an IQ test to got, an average of like 104, right, then I would say that all 11th graders have an average of 104 on this particular IQ test. Boom, there's my result. Throw it up on a billboard. Let's put it on a school website. Let's explain it to the world on the internet. Okay, there's something called random sampling. So let's say that I got 200 kids, okay? But it just so happened that the kids that I got were from a low SES, like neighborhood schools, SES meaning socioeconomic status, okay? And let's say that they Actually, let's say that their IQ was, below average, not 103, let's say below average. Then I would say, okay, the average IQ is 90, let's say, for all of 11th graders. No, that subset of kids are not representative of all 11th graders. So I don't even know what would be representative of all 11th graders, but it's definitely not that, okay? Why? We know that kids who are low SES don't have the resources to learn, to do homework, to feel safe. They tend to get worse grades and have lower performance. They usually don't have usually aren't pushed to have an education or a college education. Families tend to not value education as much as kids in other higher SES. Okay, usually have lots of big families. Okay, where the family is more important than individual progress. Okay, so those are all criteria of low SES, and over years and years and years, kids who are from low SES areas do worse. They perform worse, and it's just this problem, this huge cultural problem that we have. Okay, so that's not going to be a representative sample. Okay? How would we get a representative sample of 11th graders? Yes.
Randomly selecting 11th graders from across whatever region you want.
So, okay, so randomly selecting, how would we randomly select from 200 11th graders from all 11th graders?
4 kids from each state.
That's not really, it's not really random, but because you're already ahead of time setting, there's going to be 4 kids from every state. It's more like, it's random is more like you're kind of drawing from a hat. So you're setting it up so that it's kind of perfect in a way, has structure, but random should have something left up to chance. Yeah?
Maybe like a dice or something. I mean, it depends how big you want your population.
Exactly. So maybe the equivalent of a dice or the equivalent of drawing names out of a hat. Okay? That would be random. So if I did that, then I would more likely have the sample be representative of the population, and then I can make the claim that the IQ is this overall. Okay? So my analogy is an apple. So let's say that I have an apple. Okay? The apple looks nice and juicy and freshly picked and whatever. So it looks like a good apple. So I'm going to take a bite out of the apple, so I want the apple. So I take a bite, and I expect that the bite is going to be representative of the apple. The apple looks good, I'm just going to expect that the bite is going to taste good. Okay? But maybe I take a bite, and the bite I take from accidentally is from kind of a bruised, rotten part of the apple, and I'm like, ugh, this apple does not taste good. So I've made the wrong claim about an apple, okay? So now I might say, this apple is not good, okay? When it is, most of it is good. Do you know what I'm saying? So we're making different claims where the relationship between the apple and the bite that we took is off, okay, is not correct, so we cannot say that the bite represents the entire apple. Okay, but maybe the rest of the apple, if I ate the rest of the apple, it would represent it. Okay, but I randomly just took a bite, and that's what happened. If we take a random sample, it's less likely that we'll have, we won't have congruency between the sample and population. Okay, but it's still possible, probable. Also, did you guys do research studies in 101, or did you have to participate in research studies? Okay, so what do you think about that from a sample population point of view? think you are 101 people? You guys are a good sample.
Wouldn't it depend on the population?
It certainly would. And we don't know what that is. So first of all, we don't know if you're a good sample.
Also kind of like what the studies like looking for.
Of course, it depends on the study and what you're looking for. Okay. Hey, it could be ASU students. Okay. But if it was ASU students, would you, in 101, be representative of that? Like maybe on a test or some sort of a aptitude or something. Maybe, maybe not. It's not a random sample, okay? It's what we call a convenient sample. And that's when you read studies, that many studies, the subjects are undergraduates because the professors have undergraduates at their fingertips and it's convenient, right? Convenient to get a lot of data. So it's not exactly random, more random, okay, than other methods, but it's really not. It's called a convenient sample. So that's just one of the problems, we call it sampling error, that could happen in the relationship between the population and sample. And that is called error. And the word error is going to pop up a lot during the semester. It's even going to pop up in every single formula that we look at when we test data, okay? Lots of problems, lots of assumptions, flaws, yet we're still going to make claims about the population, okay? It's what we do. A while ago, the Southwest Airlines had a slogan. They said that they were the friendliest airline in the sky or whatever. And from a statistical perspective, I'm like, how did they come up with that? Like friendliest. How would you measure friendly?
Surveys.
By passengers?
Yeah.
Okay. But you'd have to do surveys from other airlines as well. Okay. So you've got self-report. What are types of questions that you would ask on some measuring friendly?
Did the stewardess fulfill all your needs?
All your needs. Just one question, right? That's it.
That's it.
Okay.
Well, I think the issue with that would be that everyone has a different definition of what they think is friendly.
That's true. Yep. And again, you guys are going to talk about this more in 290, but self-reports. We do a lot of self-reporting when we test subjects, and that can be, people tend to report things differently than what they actually feel. So that's problematic as well. So friendliest skies, that's a big claim. Like that means or friendliest airline, you have to survey all the airlines if you're the friendliest. Okay. Do you survey the pilots? Do you survey all of the employees? Survey the luggage people? The people who go like this, the lights. They're friendly to dogs and cats? Are they friendly? Are they like United, where they just grab people and like throw them off the plane? That kind of thing. So those are things that we think about. And how did they get that information? Was it sample or population? All this stuff. We don't know. Okay. So so for those of you who are a little bit more visual spatial, this is just this is the same thing essentially that we've been talking about. It's the population, which is individuals of interest. I have a research question. I'm interested in this group of people, and I want to know how they measure on this particular behavioral outcome. Okay. Take a sample selected from the population. Hopefully it's random. Hopefully it's generalizable. And then the results from the sample are automatically generalized to the population. That can be scary though, okay, if you're not generalizing it, if you really can't generalize it, but yet you do, okay, then you've got a lot of error there. think about medicine, okay? So you do trial after trial in the lab of, like, say, an anti-anxiety medication. The FDA approves it. It finally gets, to doctors and to the pharmacists and to patients, and they find out that they're actually, the people that were in the subjects in the trials, or the methodology somehow was not random, or there was many outliers, like some of you have said, or maybe there's something wrong with the design in general. But here's my outcome. Okay, forget about how I did it. Here's the outcome. Here's the outcome. Here's the outcome. Woohoo! We've got lots of data showing that this is the outcome. So let's put out this medication, okay, and let's decrease anxiety in everybody. And then potentially what's going to happen is it's going to be dangerous, or it's not going to do what it's supposed to do, and it'll have to be pulled off the shelves. Okay, it can't be used anymore. There's been lots of medications that have a, what was the one? Oh, you guys are way too young. Diet. One of the diet pills they used to sell were essentially speed, and so people were dying or hospitalized with heart failure because they're really high strung. Okay, they were losing weight, but it was just because they were constantly on the move. Okay, so we have lots of things, problems with statistics, and that's one of the things is the misinterpretation of that relationship. Okay, and so, we just have a couple more terminologies, and then I'll stop talking. So, the thing is that so we have our do that. So when we talk about any value that is associated with a population, we call it a parameter. Okay? When we have a value that is associated with a sample, we call it a statistic. Okay? So what are some values that are pretty typical that we would use? Just generally when we're looking at a set of data, I'm thinking of two in particular. What are some values that we use pretty commonly to describe a set of data? Oh, yes. I mean, you're talking about whole methods, and those are the big methods. I'm thinking of a little bit more like a value. Okay, so like a number. What things do we? If I wanted to know if you guys did better than on your first test than my 130 class, what value might I use?
Percent.
Well, okay, I can definitely look at the percentage of raw scores. Sure.
Average.
Okay, so most likely I'm going to take the average of your test and the average of their test, and whoever has the highest average, I'm going to say did better. So that's called the mean, right?
So are you talking about mean, median, and mode?
I'm talking about just mean, yes, but central tendency, mean. Okay, so you guys get an average of 50 out of 60. They get an average of 50 out of 60. Well, who did better? Did you do the same? Not necessarily. What if you guys, your range of scores were from 55 to 45 to 55. And the other scores were from 18 to 60, which that's definitely not the average, but they had a bigger range. Okay, what is that?
Variation.
Yay! Good. So each person, so we're not looking at just like one big blob and the main, the average, which is fine, but we're looking also at individual differences. Okay? So individual score differences. So we have the standard deviation. Okay? Now we have different symbols. Population symbol and the sample symbol.